All right, so I got the power supply in from the mail. I ordered it from DigiKey online. Sorry about the hamburger bun there. Got my counterpart making me food. But so I got it in. This basically right here, this end here is just a 3-prong plug. I wired that in, and on the other end I wired in some little bullet connectors. So what I did is over here, you got your wire, your schematics, your neutrals, your blue, your brown's your live wire, which is your hot wire, and then your green, yellow is your ground wire. Input side, your output for DC, brown is positive voltage out, blue is negative voltage out. And I put a male and a female so I wouldn't mix them up for the bananas or the bullet plugs. I went to some alligator clips so I could hook this right up to the pigtail on here, but I used the alligator clip so I can run a DMM, digital multimeter, off of it so I can read voltage when I'm doing this. But this thing was like $47 plus taxes, fees, and there's some other stuff. It ended up being like 67, 68 bucks. But I had to buy a plug and these other connectors and some wiring and stuff. It's the wiring in here is 17 gauge wire, and then I had to buy, because I can't find 17 gauge wire at the store, so I bought 18 gauge, which is fine. So now, if you look at this, is the data sheet for it. So the one I have is the HLG 120H C350, meaning, all these mean, so if you look here, HLG is the series name, 120 is the wattage, H is high input voltage up to 305 volts AC, C500 rated output current, and A is the function options. Here's your function options. So we have a HLG, so we got, that's the series name, the 120H is the rated wattage, the C350 is the current output, so 350 milliamps, and then the A is, A meaning here, the adjustable through the built-in potentiometer. So if you look here, rated current's 350 milliamps, rated out power is 150.5 watts. The constant current for voltage is 215 to 430 volts. So if you were to hook this up right now to a DMM, which we did earlier, we got 430 volts of this thing outputting. And then the current adjustment range is 175 to 350 milliamps, which is you just pop this little plug off, a little screwdriver, there's a little potentiometer in there. And it goes over all this other schematics here. Not schematics, but data sheets. There's other ones you can use, but it won't go up to, like this has more amperage, 500 milliamps, a half an amp, but this doesn't go up to 430. We want to go up to like 400 volts. This one goes up to like 300. So it talks about that in the data sheet. And you can go over all this stuff. I'm not going to go over all of it, but it's an LED lighting module. What I was concerned with is I got A. So A type, it tells you your wiring schematic right here. Same thing that's on the one that's on here. Here's your schematic, how we wired it up. And then, so yeah, that's it for the data sheet. But now what we're going to do is go ahead and we'll start charging this vehicle. Battery, hybrid, high voltage battery backup. All right, so we're back at the vehicle. Got the LED power supply right there. If you remember earlier in the part of this video, I show you how we made that and what all the specifications from the data sheet are. Well, if you look here, somebody already put positive and negative on these terminals. We took that shrink tubing off. We're just going to verify that again, because right now, if you go negative here and then positive over here, should have no voltage. Zero volts, and we want to do that on a reg so we don't arc to this. Obviously, we're going to go ahead and put that in here in 1 minute. All right, so I put my leads in there we made. So we're going to go ahead and put the plug in, see what our voltage, make sure we don't have a negative symbol. Because if we do, we're going to have to reverse the polarity, because we don't want to hook this charger up incorrectly, or this LED module. Yeah, it's already got voltage. He's at 303. It wouldn't start earlier, so I don't know if the minimum is... I think the computer's reading a little bit different with the power's on. I don't know if 300 is the minimum or 330, but we're going to go ahead and charge it up now. So there's no negative there. But if I was to reverse this polarity, then there would be a negative there. So they did label that correctly. My red lead to positive, my black lead to negative. So we pulled it back out, back to 0 volts, and we're going to set up our LED. So now we're checking the power supply. We got hooked up to 115, 120 on the outlet over there. Coming through our leads here up to our alligator clips. We're just checking that's to 430 volts output from this LED power supply. Alrighty, so we got the power supply hooked up to the alligator clips going in with that plug-in. Then we got our DMM multimeter checking the voltage. We started at like 305, 306. We're at like 312, 313 now. And we're slowly going up. I got it on the lower amperage, but you can dial the amperage in right there. So we'll just let it keep rising for a ways, and then we'll try to start it. Alrighty, we're continuing the charge. We're at 320 volts DC on the lower amperage setting. Alrighty, so we're at 331 volts roughly right now. Alrighty, so we unplugged it. We had a little bit of a voltage drop just for everything catching up, but we plugged it back in. I do have my oscilloscope hooked up, amp clamp, right here. And I'm all the way counterclockwise on the little potentiometer in there for the current adjustment. And if you look here, I'm reading about 165, 170 milliamps, which is the low side. But now if I go ahead and turn this thing up all the way clockwise, it's going to charge faster. Now I'm at 385 milliamps. So we're just at a charger, fasting charging right now. So we'll let it charge a little bit more. We'll get above 330 a little bit. We'll unhook everything, hook the main plug up in the connector, and we'll see if this thing starts. Turn that dial on the potentiometer for the amperage. I put it roughly in the middle. So we're like 200, 202 milliamps. So continue to let it charge. And we're at 333 volts DC. When you unplug this thing, don't touch anything because there is capacitance in here still. Capacitors, it holds energy for like 20-30 seconds to go down. I found that out the hard way. I got shocked pretty good. Alrighty, we're continuing the charge. We got to like what, 330, 340,
336.
336, and then we hooked everything back up and tried to start it. It wouldn't start, but we were monitoring and trying to start it, and the voltage dropped way down. So I believe, like I said, I don't know if the minimum is 300 or 330. I know the nominal is 330, but it dropped so far down. And when we were first charging it, it was this number volts was going up real quick, but now it's slowing down, which is good. So it's balancing everything out with the charge. So we're going to continue to charge it, see if it starts, and then we'll go from there. So we're continuing the charge. So we're at 347 volts DC. I hooked the amp clamp back up to show you the milliamps. Here is go slower time scale. 367, 370 milliamps. So we're continuing the charge. And then we'll continue to do this. It's going up very slowly, so I believe it's taking a good charge. So I hooked everything back up, battery control module connector, and then the two positive negative orange cables. Got the lead hook up to the multimeter. We got 332 volts DC. I got key on, engine off. I got the scan tool hooked up. Just want to show you here. If we go to the control unit, PCM, read codes. While that's pulling up, we have no security light because everything's hooked back up, and we already did that programming from, I believe it was part 2 or 3. I think it's part 2 of this series. So that's all good. We're just gonna have one code in here, a P1000, which means it hasn't done its test yet because all the codes have been cleared out and hasn't been driven, which is we got that. So there's no battery control module codes like there was before. So if you go to the BCM battery control module, we got to charge our other battery up because it's getting a little low there. If you go to read codes, it's going to do a self-check. You probably hear the fans on the battery. There, they turned on. It's doing a self-check. Those fans in the battery, they cool everything. So it's communicating there. I expect to see no codes here, and I'll show you why. Fans turned off. No fault codes. Before we always had that issue. Go to live data. And if you look at this live data, average state of charge 2.99%. Temperature is 1 degree Celsius. No fault for the battery module. There was a fault there before. Battery pack integrity says okay. Before it had a fault. Here's where we're concerned is battery pack state of charge. It's still 0%, but the voltage is 332. Self failure, no fault, which we had earlier. No codes, obviously. You get all this other data in here that we don't need right now. But our voltage is above the 330 nominal, which is 330. But we still have a state of charge of 0. So when I try to start it, it won't actually start still. I'm cranking it right now. So we're going to have to let it charge to get this percentage up, up higher, and then we'll go from there. So I think our voltage is there, but we're not up to the, status of charge. So like if you take a car battery, 12.6 volts is 100% charge. You get down to like 12, it might be 75%. You get down to like 11 and a half, you're like 25% or 0% when you get below that. So I think that's where we're at with that. This thing's got to charge for a few hours. Then we'll come back and check our status of charge and get this thing running and go from there. So I mentioned earlier that obviously we're charging this battery up. We got the DMM off. We're going to hook this plug back up and we're going to get all charged up. But, we had 340 volts. But a 0% charge, and I believe on this one, I know the nominal voltage is 330. The full voltage, according to the service manual, is 400, or approaching 400. But that point being said, is why is it below? It's above the 330 volts DC. And there's no faults now, like we proved, but there's status of charge, or the SOC is 0%. Just to relate that to this, if you had a regular car battery. And I got these numbers from Actron. These are actual numbers that are published out there. 12.6 volts DC on a car battery, not the high voltage battery, but a regular car battery is 100%. Why 12.6? Because you got 6 cells at 2.1 volts per cell. So that's where you get 12.6. So 12.6 is 100% charge. 12.45, 75%, 12.3, 58, 12.15, 25. So if you look from 12.15 to 12.6, you're talking point, of a volt, right? And you're already down 25%. So you start getting under 12 volts, you're at 0%. Same thing with this one. We're under 400 volts. We're at 300 some, 330, 340, but we're still 0%. So what we're going to do is we're going to hook this thing back up, let it charge for hours, monitor it with the DMM there, the digital multimeter, get it up to that percentage on the scan tool, so you can actually start reading the percentage, because I don't know if Ford cuts these off at, it's at 40% or 60% in the manual, so it saves the battery. And that's why it's not starting. So it just needs to charge longer with our LED power supply. We'll get it charged up, and then we'll make the next part of the video, which will show it running and go through all the drivability tests.